Very good evening, everyone, and welcome to Om Institute. So, the GATE 2025 examination commenced today. That is the 1st of February. And tomorrow, the EE students are going to write down the examination. That is on 2nd of February. Yes, dear. Yes, tomorrow, EE students are going to write the examination. All right. Yes. Stuck up into some things. The session started late, but yes, finally, we are live. Yes, come on, quickly update all your friends that yes, we are live. And guys, the questions memory based, because official paper of course is not released by IIT. It will be released only after all GATE exams are over. Okay, but for the common subjects that you might be looking for, especially that can be interesting for EE students, for EC students, and especially EE paper being tomorrow. So you can have a look how the paper and how the difficulty level was. Nothing to panic out of this video. It's all about yes, it's all about how the variety of questions were and whether you are able to attempt it or not. And these are the 4 subjects that we are going to target here: mathematics, signal and systems, control systems, and digital circuits. These are the different areas that we are going to target today. All right, so yes, quickly let's get started one by one. Okay, and these are all memory based question in discussions with the students, and whatever students shared us in the telegram and etc. We have got these questions, and if you also remember any other question other than that, you can also reply in the chat box. You can also let me know in the chat box. Okay. Okay, great to know. No, don't worry. See, it will feel like you have forgotten, but it's not like that. When you go into the exam hall, if you have honestly prepared, you start looking into the questions. Okay, definitely you will gain the confidence. It happens normally one day before. Students might feel, little nervous and all. Okay, guys. So yeah, let's get started first of all with the question. Just a second. Yes, Ishita, COA, one question can be expected, of course, not beyond that, but one question can be expected. Okay, guys, so finally starting with the first question. Okay, starting with the first question. Okay, so yeah, that's what, collecting the questions, and, it was not possible to get it typed in the short period. So some screenshots I have attached. Let me just have a look whether that looks fine in front of you. Yeah, it's totally clear, I think. Okay, it's totally clear. It's totally clear. Thank you, Vasant. So yeah, starting with mathematics question, dear. Starting first with the mathematics question. Just a second, dear. Just a second. Issue was there, but I think now it is clear. Let me check the audio once again. Yeah, this was the first question. But I think now it is clear. Yeah. It looks fine now. Yes, guys, let's get started now. Let's get moving ahead. So sorry. Yeah, so this is a mathematics question. A is a 2n cross 2n matrix for n greater than 2. Aij, the elements are given by minus beta I plus j for if I plus j is even, and beta if I plus j is equal to odd. What can be the rank of the matrix A where n is greater than 2? Okay, so of course, let's try with the least value. See, even if you try for n equal to 1 and 2 also, the result will be matching. But since they said that the matrix should have the n greater than 2, okay, so n greater than 2, that means let's try n equal to 3. If anybody appeared in the exam and attempted the question, you can also let me know the answer. Okay, so if I try with n equal to 3, the matrix size 2n cross 2n would become 6 cross 6. Okay, but now, dear, when you try to form this 6 cross 6, what is the first element? Any size, it is A11, and 1 plus 1, 2. The first element is even, and if it is even, if I plus j is even, the element will be minus beta. The element has to be minus beta. Sorry, yeah. So element has to be the minus beta. Then we know that A11, A12, A13, when you keep changing the elements, okay, so odd, even, 1, 1 is even, then 1 plus 2, odd, 2 plus 1 plus 3, even, okay, 1 plus 4, odd, like that. So the elements will be alternating. Even if you go down, if this is A11, this is A21, 2 plus 1, again odd. And for odd, what is the value you have to take? If I plus j is odd, it has to be beta. Okay, so minus beta, beta, then minus beta, and then minus beta and beta. And if I go down, it is beta and minus beta. Finally, beta and minus beta, beta and minus beta. Coming up to here, because they are confirming that, you know, the number of rows and columns are even. Okay, so it's again minus beta, beta, minus beta and beta, minus beta and beta. Next element would be beta minus beta, beta minus beta, beta minus beta. And next is minus beta beta, minus beta beta, minus beta beta, and the last row will be again beta and minus beta, beta and minus beta. I think, you know, even if you are seeing the question for the fresh time, and if you see the matrix here, if you are able to see the matrix here, okay, if you are able to see the matrix here, you should have guessed what is the answer. Okay, yes, so Prashant, Gate Journey, Nageshwar, Joshna, all of you say the answer 1. Yeah, looks like it's correct. The answer is 1 only. Very good. The answer is 1 only. Correct, guys. See, basically you are able to see that, you know, the first, third and fifth rows are similar, but not only first, third and fifth row. Okay. Even the second row, see, the second row and the fourth row and the sixth row, they are negative of the above row. Okay, so second row, fourth row, sixth row, they are all negative of R1, but all the odd number rows are same. R3 and R5, they are equal to R1. That means only one independent row and the rank has to be 1. Okay, only one independent row. Okay, so rank equal to 1. Only one independent row, rank equal to the 1. Okay, the rank is equal to the 1. Clear? Let's move ahead to the next question. Let's move ahead to the next question. Right. Okay, correct answer, guys. Next one, if a equal to minus 1, x and minus, sorry, this is not minus y. Okay, this is minus 4, minus 1, x and minus 4. And the one of the eigenvector is alpha 2 alpha for alpha not equal to 0. For alpha not equal to 0, what is the value of x? What is the value of x? This is simple only, dear. Okay, this is simple only. You know, if anything, if any x is eigenvector, you should always try ax equal to lambda x. I will start with ax equal to lambda x, and if I start with ax equal to lambda x, that means minus 1 and the x and minus 4 multiplied by alpha 2 alpha should be equal to lambda into x. Okay, lambda into this eigenvector. So dear, when you take up the first element minus alpha minus 2 alpha, so what is the equivalent? Minus 3 alpha, and the second element alpha x and minus 8 alpha. 2 into 4, correct, minus 8 alpha. This has to be equal to lambda. I multiply inside lambda alpha and 2 lambda alpha. Done, dear. Okay, so what is the first to first element? If you compare, alpha cancel, lambda is minus 3. Okay, so if they ask the corresponding eigenvalue, it is minus 3. Now the next one, they are asking the value of x. So alpha x minus 8 alpha is 2 lambda alpha. Alpha is cancelled out from here also. So x minus 8 is equal to 2 lambda. That is minus 6. So what should be x equal to? 8 minus 6. X should be equal to the 2. X should be equal to the 2. Now let me check how many of you have got it correct. Yes, Nageshwar says 2, Harshvardhan says 2, Prashant says 2. Correct answer there. Yes, so x is equal to 2 is the correct answer. X is equal to 2 is the very correct answer. Moving ahead to the next question. Yes. Yeah, a very basic question. Calculate the residue of the poles, and both the poles are simple in nature. Okay, both the poles are simple in nature. Okay, so what is the residue formula you are going to use is limit of z tending to 0. Okay, z minus a into fz, because both the poles are simple in nature, first order poles. Both the poles are simple in nature. Okay, so corresponding to z equal to 0. Okay, if you take z equal to 0, so what is going to be the residue? Residue will become limit of z tending to 0. I'm sorry, here in general z equal to a, limit z tending to a, z minus a fz. Okay, so for z tending to for the pole of z equal to 0, limit z tending to 0, z into fz that is 2z plus 1 upon z, z minus 1. So z and z factor getting cancelled, 1 upon minus 1. So one of the residue is minus 1, and keep confirming me exactly if this was the question or something else. That you can keep confirming me, right? Okay, that you can keep confirming me. And for the z equal to 1, the other pole is at z equal to 1. The residue will be limit of z tending to 1, z minus 1 into the fz. Okay, so z minus 1 cancelled here, and then it becomes 2 plus 1 is divided by 1. Is this correct? 100% correct. So then the answer becomes 3. Then the answer becomes 3. Correct. Minus 1 and 3. Yes. Minus 1 and 3. Okay. Correct. Joshna correct. HD Sport correct. Minus 1 and 3. This is what is the answer. This is what is the answer. Next question, dear. The next question. A basic integral question, and if you remember the Wallis integral, then this question is very easy for you. Okay, the Wallis integral or the beta function, but I always, if integral powers are there, I always support Wallis integral. Sum of residues pucha tha, then 2, okay. So that's what, these are all memory based. If they are asking sum of residues, okay, if they are asking sum of residues, so no problem. Then also not a problem. No? Basically, your calculations is done. So sum of residue minus 1 and 3, it would be 2. No problem. Okay. So yeah, that's what memory based. Sometimes you don't get the perfect question, but yeah, the theme of the question was there. Residue. Anyways, you have to calculate whether it is sum of residue also. Yeah, coming here. Okay, so Wallis integral is the best thing to take up here, or the second option is the beta function. Okay, the second option would be the beta function. So let's take it here. But Wallis integral limit should be 0 to pi by 2. That is the thing you have to take. Okay, that is the thing you have to take. Okay, so yeah, let's take it out. First of all, the limit is minus pi to pi. But remember, cos theta is even function. Okay, so any power of course, is even function. And because it is even symmetric. Okay, because of even symmetry, what is the first thing I will do? The integral will become twice integral 0 to a. Minus a to a, so twice integral 0 to a, correct? But then, see the type of function, both are having cos even power. Okay, so see, cos of 180 minus theta is minus cos theta. Cos 180 minus theta is minus cos theta. But because you are going to take cos power 4, okay, when you take cos power 4 or even cos power 6, okay, whether you take 4 or 6, any power, even power, na, both of them will be converted to cos power 4 or correspondingly 6. What I mean to say here is, if this is fx, f pi minus x equal to fx. Okay, you can think in this way, f of 2a minus x equal to fx. Okay, where I have assumed this pi as 2a. Okay, so if f2a minus x equal to fx, dear, if f2a minus x equal to fx, so integral can further, integral 0 to 2a is further twice integral 0 to a. That means this becomes total 4 times integral 0 to a, and a will be pi by 2. Okay, now when you make the limit 0 to pi by 2, now it is directly Wallis integral. Okay, cos power 4x, cos power 6x dx, correct? Cos power 4x plus cos power 6x dx, correct? So yeah, let's complete the calculation then. Let's complete the calculation, and then I will see, I put the mobile down right now, and then I'll see what are the options that you have taken up. Okay, so cos n power n, okay, cos power nx, so n minus 1 factorial, that is 3 double factorial upon 4 double factorial into the k factor, and because even power, so k should be pi by 2. Next one, okay, cos power 6, so 5 double factorial, n minus 1 double factorial upon n double factorial into k. Okay, for even power, k should be pi by 2. Okay, so pi by 2 outside, 4 pi by 2, 2 pi, and rest of the calculation inside 3 double factorial 3 cross 1, 4 double factorial is 4 cross 2. Next is 5 into 3 into 1 divided by 6 into 4 into 2. Okay, equal to something that you can calculate and write down the final answer. Okay. Okay. Yeah, at least moderate paper GATE journey will expect for EC. Okay, it's because see, mathematics is simple. But when you go to signal and system, some questions are good. Even in control system, some questions are decent. Okay, mathematics and digital, as far as the questions I have got, they are easy. Okay, so guys, you can complete this calculation. I just leave it to you. Let's go to the next question. Let's spend time on looking into more question. Okay, finally, you can write down the calculated answer. Okay. Finally, you can write down the calculated answer. Now, again, another simple question. What is the solution curve? There were 4 options, students say, but what is the solution curve? Basic differential equation question, variable separable, y into dy is equal to 9 dx, is equal to 9 into dx. Okay, and integrate on both the sides. It is variable separable. So, y square by 2 is equal to 9. Okay, sorry. Yeah, correct. 9 into x dx. X is there. Okay, so 9 into x dx. So x square by 2 plus constant. Okay, so tell me what solution curve it is. What solution curve it is. So you can write down this equation as x square, okay, maybe divide by 2 by 9 minus y square by 2 is equal to some constant that you can call it a square also. So it's basically the equation of a hyperbola. Okay, it's the solution represents a hyperbolic curve. Correct, dear? Okay, tell me whether the data and the question is correct, whether you found this in the exam. Okay, right. So it has to be hyperbola. Okay, moving ahead to the next one. Digital circuits. Okay, a question tip. It's a question on basically overflow concept. Okay, 5 in decimal plus 5 in decimal. You have to write down the answer in 4-bit 2's complement form. 4-bit 2's complement form, dear. But when you take 4-bit 2's complement form, okay, what is the range of number in 4-bit 2's complement form? Because 5 plus 5 in decimal corresponds to 10. But whether can you represent 10? Okay, whether can you represent 10? So if you talk about, the range, okay, the range in the 4-bit format, the range in the 2's complement 4-bit format should be -8 to +7. Minus of 2 power n minus 1 up to plus of 2 power n minus 1 minus of 1. Correct? Okay, so the number is going to be out of range. But whatever the number has been calculated, they don't say whether it is a correct answer, incorrect answer. When you write this, now what is 5 plus 5? Okay, 5 is within the range. That is correct. Okay, 5. Okay, in the 4-bit format 0101. That's a positive 5 number. Correct? Okay, so when you add, okay, 0101, 0101, so it is 1 plus 1, 0 carry 1, then again 1, 1 plus 1, 0 carry 1, and again 1, 1010, which is not 10. Okay, the point is, I think they have made the option simpler. They have made the option simpler. They could have given one option as 10, decimal number 10. Okay, that is where students will get confused. Okay, 5 plus 5, 10, and the binary conversion of 10 is 1010. They could have done that, but they have made the answer simple. Okay, now why? Because 1010, if you look into the sign, the MSB bit 1, that means it's a negative number. That means it's a negative number. Okay, so if it is a negative number, it would have been stored by taking the 2's complement. So I further take the 2's complement of this. Okay, so 0101 is the 1's complement. Add 1, so it becomes 10. Okay, the magnitude of the number is 6. Okay, sign is negative. Okay, so combining it, magnitude is 6, sign is negative. So it's a number which is -6. Option number B. Option number B. Yes, Nageshwar, Ishita, your friend, Gate Journey, Varsha, correct answer. It's B, Akbar, correct answer. Okay, dear, let's move ahead to the next one. Okay, so this was a fundamental question of digital circuits. Yeah, another very fundamental question. Okay, very fundamental question. Okay, a basic De Morgan's law, where X is given to you as A bar, B bar plus A bar, C bar. So let me write it as A bar common into B bar plus C. What is the X bar? Okay, what is the X bar? Okay, so, when you take the complement, okay, just first take the dual of the function and complement each variable. Okay, so this plus will become into, okay, this into will become plus, and all variables complemented. So B bar, C bar should be B, B bar should be B, C bar should be C, and A bar should be A. So A plus B, C, option number B, finish. Okay, basic De Morgan's law. Okay, yes, Joshna, Tech Trek, correct answer, option number B it is. Next question, dear. Okay, next question, dear. Okay, so what is the next question? A very basic multiplexer question. A very basic multiplexer question. Okay, so a multiplexer, first a 4x1 multiplexer is given with the select lines as PR and the input combination 0, 1, 1, 0, which it should be a XOR. If you know very clearly about the mux, if you have even done some decent practice about mux, it should be the first one is representing XOR. Okay, then it is cascaded with a 2x1 mux. The output of the first one goes to the 0 line. And the I1 input is fixed at 1. The select line here is R. What is the final output? Okay, what is the final output? Let's say, this is some output, like suppose this is some Boolean function f. Okay, what is that Boolean function f? Okay, so first, let us solve the output here. What's going to be the output here? What's going to be the output here? It's going to be, you know, P bar R plus P R bar. Okay, you know, 0, 1, this is I0, I1, I2, I3. So 0, 1 and 1, 0 combination will come. Correct. Okay, P bar R plus P R bar, or as I told you, it is P XOR R. Okay, now what is the output F? What is the output F? Now the select line 0. Select line 0 means R bar to be multiplied by this output, which we have got it as P XOR R. P XOR R. Okay, plus R into 1. If select line is 1, the I1 input is selected. The I1 input is selected. Okay, so just if I open this, it is R bar into P bar R plus P R bar plus R. Okay, so the first term R bar into R cancelled. Second one P R bar into R bar is R bar plus R. Okay, and dear, what is R plus R bar P? It is simply R plus P. R plus R bar P, R bar is absorbed, R plus P it is. Okay, so answer is R plus P or P plus R. Okay, check the data, check the question, let me know if everything is in place, if everything looks okay. Okay, yes dear, moving ahead to the next question then, the next question of digital. It is here in front of you, the next question of digital. 4 cross 1 marks inputs are P and Q. Okay, Kareem Mohammed says that the 4 cross 1 marks inputs are P and Q. Okay, so that is a correction that I am getting. Okay, this is what I got, no problem. What you are telling, P and Q. So let's take it as P and Q, then not a problem. Okay, then it becomes P XOR Q. Okay, the first output here is P XOR Q, and then we will take it accordingly only. This is P XOR Q. Rest is okay, I think. Let me know if the second input, the second multiplexer data here is correct or not. Okay. Select lines P and Q, correct. Saurabh also, gives that same result. Okay. So now it is going to be how much? Okay. Then also, see, now I will write it as how much? R plus R bar into P XOR Q. No problem. P XOR Q. Okay, but again, R plus R bar into F. Okay, R bar will be absorbed. It is R plus F. So R plus P XOR Q. Okay, rest on depends on the option R plus P XOR Q. Okay, how options are given, because I don't have the options. Okay, R plus P bar Q. Check it out. Okay, or P bar Q can further, you can write it as PQ bar plus P bar Q. Okay. Okay, so if this is the case, then the answer is R plus P XOR Q. Okay, Varsha says, so guys, you have got that corrected. Fine. Okay, so select lines was R and P and Q, so I have corrected that. Next question of digital. Okay, a fundamental only, basic question coming up here. Yes, a fundamental question from sequential circuits is coming up here. 2D flip-flops are given. Okay, so let me clearly write down. Okay, that, these are the two flip-flops, outputs Q0 and Q1. The Q1 bar is considered as some output F. The Q1 bar is considered as some output F. Okay, and this Q1 bar is coming up here. Okay, and also fed to the input to the first D flip-flop. Okay, this is some control input. Both the counters are working on the same clock, so it's a synchronous circuit, and the frequency of the clock given is 12 megahertz. Okay, now check whether everything is in place or not. Okay, what is the frequency at this output F? Okay, for the control input 0 and 1, taking 0 and 1 both, taking control input 0 and 1, in both the case you have to give me the output F. Okay, so no problem dear, if control input 1 or control input F. See, anyways, what is sure is what is the next state of the Q0. Okay, it's a D flip-flop, the Q plus equal to D, the Q0 plus equal to the D0, and D0 is equal to the Q1 bar. The D0 is equal to the Q1 bar, correct? The D0 is equal to the Q1 bar. Now, Q1 plus, what should be the Q1 plus? The next state of the Q1 flip-flop is equal to D1, but what comes to the D1? Okay, what comes to the D1, that depends on the control input. So better to take the control input and then write down the value. Okay, then write down the value. Let's make it simple. So if I take the control input as 0, then, okay, then it is Q0 plus 0. This will be Q0 only. Okay, so Q1 bar into Q0. What is the D1? Okay, what is the D1 in that case? It will be Q1 bar multiplied by the Q0, and the Q1 plus will be equal to the D1, that is Q1 bar into Q0. Okay, so now let me write down the state sequence for this one. let me write down the state sequence Q1, Q0, of course, by default starting 0, 0, the reset condition. Okay, reset condition. Yeah, many of you say answer is 4,6, right dear? That means option number A. Okay, all options are in megahertz. Okay, the frequency, all options are in megahertz. Clock frequency also given in megahertz. Okay, so 0, 0. Now see here. Okay, Q1, Q0 bar is the complement of Q1, the current state of Q1. So if this is 0, its complement will be 1. If this is 0, its complement is going to be 1. Okay, and then, okay, what is the Q1 bar into Q0? Q0 0, so Q1 bar, the Q0 0 means Q1 plus will be 0. So next state is 0, 1. The complement of Q1 will be placed here, that is 1. Okay, now 0, 1. Q1, Q0, 0, 1. So 0 bar into 1, 1 into 1. So yes, next state of Q1 will be 1. Okay, now this complement comes up here 0. Q1 bar into Q1, the previous state Q1 was 1, the 1 complement 0 and the Q1 plus next state will become 0, that repeats. There is a repetition. So what is the modulus of this counter? Okay, there are 3 unique states, then it is repeat, it is mod 3. It is mod 3. Okay, so what is the frequency at the output F in this case? Clock frequency divided by mod 3, it is 4. It is 4 and hence there is only one option with, the first frequency as 4 because it is in sequence. They mentioned for the control input 0 and 1 respectively, it is 4,6. But next one also we can solve, not a big deal. Nah? We can solve the next one also. Just for understanding, with a clear understanding of the concept, let's solve the next one also. Okay, so what is there in the next one? Have a look into this. What is there in the next one? If I take the control input equal to 1, okay, this was 0 and now if we take the control input equal to the 1, if we take the control input to be 1, okay, so what is going to happen? 1 plus Q0 will be 1. What comes here is 1. So D1 is just Q1 bar. In that case, D1 is just equal to Q1 bar into 1 and that is only Q1 bar. Okay, that is only Q1 bar. But what I told you, okay, the Q0 plus is also Q1 bar. The Q0 plus is also Q1 bar. So both are only Q1 bar. So if I write down the state sequence now, Q1, Q0, starting with 0, 0, whatever is the value of Q1 bar. So Q1 is 0, its complement 1 and its complement 1. Okay, then next, what is the Q1? It is 1. So its complement 0 here also, its complement 0 here also. So repetition occurs. So it is only mod 2 here. In this case, it behaves as a mod 2 counter. Okay, so what is the frequency F at? Will be 12 by 2 and that is going to be 6. Already we tick mark the answer 4,6. 4,6. Okay, see, frequency at Q1 or Q1 bar will be same only the waveform will be inverted. Okay, so whether the frequency at Q1 or Q1 bar, okay, both will be similar only. The frequency of output, clock frequency divided by modulus number. Okay, they will only have inverted waveform, but the frequency and the duty cycle of them would be matching up. Sorry, not the duty cycle, but the frequency would be matching up. Okay. Yes. Right. Next one. Let us see what is the next question. Okay. Let us see what is the next question. Okay. So question on signal and system. Okay. A discrete time system is defined by the input-output relation yn equal to 1 by alpha yn plus yn minus 1 plus xn, where xn is del n minus p. The xn input is given to you as a shifted impulse signal for p greater than 10. What is the value of yp plus 1? What is the value of yp plus 1? First of all, it's better to, convert this into the Z transform. You can convert this into the Z transform very easily. Okay, so what is the Z transform of this? Yn Z transform, yz. Okay, shift all the y terms on the left side. So minus 1 by alpha, yn minus 1 Z transform, time shifting yz Z inverse is equal to xn Z transform xz. And what is the Z transform of impulse? Impulse Z transform 1, but delta n minus p will give you Z power minus p. Will give you the Z power minus p. Okay, right, again because of the shifting. So overall, what is the yz? Yz, if you take common, so 1 minus 1 by alpha Z inverse is equal to Z power minus p. Okay, from here, you can write down the expression for yz as well. Okay, what is the yz? Yz is turning out to be multiplying by alpha on the right side, alpha Z power minus p divided by alpha minus Z inverse. Divided by alpha minus Z inverse. Okay. Or if you, if you keep in the 1 by alpha format only, it is Z power minus p upon 1 minus 1 by alpha Z inverse. Okay. So what should be yn? Okay. What should be the yn? See, if you remove the Z power minus p, if you remove the Z power minus p, Okay, then 1 upon 1 minus az inverse, a power n un, a power n un. Okay, but z power minus p is corresponding to the time shifting. So it should be how much? A power n minus p, u of n minus p. U of n minus p. What is the value of yp plus 1? Okay, now what is this answer? It is equal to 1 by alpha raised to the power n minus p for n minus p greater than equal to 0. That means for n greater than equal to p, unit step equal to 1 for n greater than equal to p. Okay, so what is the value at p plus 1? Okay, correct. Okay, so the value of time is ahead of p. So value at p plus 1, 1 by alpha, p plus 1 minus p. Okay, so p and p getting cancelled. Answer is 1 by alpha only. Answer is the 1 by alpha only. Correct, dear? The final answer is 1 by alpha. Yes, dear, let me know whether this was the exact question. Yes, Akbar, one and the same thing only. Correct, 1 by alpha. Ishita, correct. Moving ahead to the next question, dear. Moving ahead to the next question. Find the fundamental time period of the magnitude. Fundamental time period of the magnitude. Now, this is really a good question. E power j5t plus e power j90. Okay, and there are 4 options: pi, pi by 2, pi by 5, pi by 9. See, I don't want the fundamental period of the signal xt. Fundamental period of the magnitude of xt. Now, see, magnitude of xt. What's going to be the magnitude of xt? Okay, what is the signal xt given? Okay, let's have a discussion on to that. E power j5t plus e raised to the power j90. Correct, dear? Okay, now what is the magnitude? If I want the magnitude of xt, then it is becoming how much? First of all, you can write down this, na? Cos 5t, okay, and from here cos 90. That is the total real part. Okay, plus j, okay, imaginary part, sin 5t plus from here it's going to be the sin 90. Correct, dear? It's of the form x plus jy. So magnitude, when you want, you're going to find the magnitude as what? Let me say this is some a plus jb. So magnitude, you will start finding root over a square plus b square. Now, when you do the root over a square, see, cos square plus sin square will be 1. Cos square plus sin square will be 1. Okay, cos square plus sin square will be 1. Again from here, cos square theta plus sin square theta 1. Now from here you get, okay, 2ab term, that is 2. 2 I'll take common only. Okay, so cos 5t cos 90 and plus sin 5t sin 90. Okay, cos a cos b. Okay, plus sin a sin b. Okay, let me see what you have marked in the answer. Okay. Okay. Pi. Akbar says pi. Your friend says pi. Okay. Yes, Likita. 2z plus 1 upon z. Z square minus 1, or is it z, z minus 1? I got the question as z, z minus 1. And I think students acknowledged also. It has to be z, z minus 1. I think that is what was the question, Likita. Okay. Yes, dear. So let's come to this one and see what is the correct answer. Now, cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b. Okay, can be further written as cos of a minus b. This is a cos a minus b result. Okay, a minus b, the difference is 40. Okay, now 2 common. Okay, 1 plus cos 2 theta. 1 plus cos 2 theta is further 2 cos square theta. Okay, so overall when you take the under root, under root of 2 is 2 and cos square under root will be cos. But remember, I want modulus of xt. Remember, I want modulus magnitude of xt. That means magnitude of 2 cos 2t. Okay, so what is the magnitude coming up, dear, on solving? Now let's come up here. Okay, what is the magnitude coming up on solving? Magnitude, when I solve by root over a square plus b square, is turning out to be 2 cos 2t. Okay. Okay, if it was only cosine, think this way, if it was only cosine, okay, then you could have said, okay, the period is 2 pi by 2, that is pi. Okay, but it is modulus of cosine. Okay, how will a modulus of magnitude will look like? How this magnitude part will look like? Is it not going to look like this? The time period becomes half. Okay, this is pi by 2, this is pi, this is 0. Okay, this is 2 pi, correct? So time period here becomes how much? Okay, the time period here becomes how much? Now just check. The time period here becomes how much? Because, okay, we have converted it, okay, to the regular, the magnitude of the cosine waveform. to the magnitude of the cosine waveform. Correct. Okay, sorry, frequency is 2, na? Sorry, frequency is 2. Then these points I have not written correctly. The points I have not written correctly. Sorry, this becomes 0. Okay, and then this becomes actually pi by 2. Okay, because what I want here is, correct, this if I take, na, this is omega corresponding to 2, right? So at 2 into, yeah, this is pi by 4, this is pi by 2, okay, because omega is 2. Okay, so Likhita still says z square minus 1. Okay, so no, the period here is pi by 2. The time period is pi by 2. Okay, it is the modulus function, na? It is the modulus function. The period will be pi by 2. Option number B, correct. Okay, I have seen some students taken the answer as pi, but the correct answer is pi by 2 only. The correct answer is pi by 2 only. Pi by 2. Okay. See why? Because, okay, cos 0 is 1. If you take cos 2 pi by 4, then you get cos pi by 2. Okay. And then cos 2 into pi by 2, cos pi minus 1, but I am taking magnitude. Okay. So it will become 1 only. Okay. The answer is pi by 2. It has to be pi by 2. Okay. It has to be pi by 2. Or even if you substitute in the function, see. Okay. Time period. I am telling pi by 2. Okay. So let's shift the t by t minus pi by 2. It becomes cos of 2t minus pi. Okay, right, or cos pi minus 2t. Cos 180 minus theta is minus cos theta. Listen, cos 180 minus theta is minus cos theta. Okay, if it is only cosine waveform, then the time period pi by 2 will not match. But if I am talking about magnitude, minus cos 2t or cos 2t is same only, na? Okay, so magnitude is pi by 2 only. Even if you substitute t minus pi by 2, then also you get the same thing for the magnitude of xt. For the magnitude of xt. Is that correct, dear? So answer is pi by 2, option number B. Answer is pi by 2, that is option number B here. It's not pi. Okay. It's not pi. Done? Next question. Okay. A good question, a good conceptual question from the DTFT and DFT part. Given that xn is equal to 1, 2, 2, 4, okay, and x e power j omega is the DTFT of xn, and omega k, the discrete frequency, 2 pi by 3 into k, and that means, okay, 2 pi by 3 into k, so this corresponds to the n, okay, they are considering a 3-point DFT in that case, and let yk be this x, when you put the omega as omega k, that means you have discretized the DTFT, that it becomes DFT. Suppose that DFT is yk, okay, what is y0? I mean, y0 means, okay, this yk is this yk you have to suppose it is the DFT of some signal yn, small yn. What is the value of y0? Small y0. Okay. Conceptual, dear, it's conceptual. Can we write down the DTFT? Why not? DTFT has a simple formula. Okay, so what is x e power j omega? X e power j omega, or let me simply call it as x omega, the DTFT is given by summation xn e power minus j omega, and that we all know. Okay, summation generally from minus infinity to infinity, but xn is only a 4-point signal given to you, 1, 2, 2, 4. So what is this DTFT? I am starting with the DTFT calculation. So what is this DTFT? Okay, the first 1 e power 0, okay, that is 1, then 2 e power minus j omega, then again 2 e power minus j 2 omega, and 4 e raised to the power minus j 3 omega, correct? Okay, now what is the omega k? The discrete frequency is given as 2 pi by 3 into k, and as I mentioned, then this is a 3-point DFT calculation. So when you write down yk, they mentioned the yk is x of omega k, that is x of 2 pi by 3 into k. So I'll put down omega equal to 2 pi by 3 into k, but the important point is when you put down, this is e power minus j 2 pi by 3 into k plus 2 e raised to the power minus j into 2 pi by 3 into k. Last term if you see, e power minus j into 3 into how much? 2 pi by 3 into k. But dear, what is the last term? 3 cancel and e power minus j 2 pi k. Cos 2 pi k, j sin 2 pi k. Answer will be 1. Okay. This part it becomes e power minus j 2 pi k, and that is equal to 1. And because it is 1, so only what is left is again a DC term 4. Okay, so the final yk, So the final yk, there is another DC term that is equal to 1 and that is corresponding to 4 times. So 1 plus 4 is 5. Okay, plus some e power minus j. Okay, it was 2 here also, I think. Yeah, plus 2 e power minus j 2 pi by 3 into k plus 2 e raised to the power minus j 2 into 2 pi by 3 into k. Now, what should be the DFT formula? The DFT formula is given by summation n equal to 0 to n minus 1. What is the value of n? N is 3. So, summation 0 to 2, n minus 1 is 2. Y of n, okay, e power minus j 2 pi by n, 2 pi by 3 into kn. Okay. So, dear, when you open the summation, automatically the first term y0 e power 0, 1, the first term constant corresponds to the y0. The first term constants correspond to the y0. Okay, so what I am able to say that, this is what is y0. Please check it out. Right, let me say what are the answers you are giving. Okay. Yes, Likhita, there will be some marathons around EMTL and EDC and some more practice sessions on signals for EC students after this weekend, after the EE exam. Okay, this is y0. This should correspond to y of 1. This should correspond to y of 2. Because if you put n equal to 2, then you get e power minus j 2 pi by 3 into 2k. Correct? Okay, so what is the value of y0 is 5. Okay, what is the value of y0 is 5. Correct, Likhita? Y0, I think they asked. That is what is the question I got. Okay, the y0 is 5. Done, dear. Okay, so it was a good, conceptual question that you can handle easily if you are clear with the calculations and the fundamental formula. Okay, the answer is 5. Moving ahead to the next question. Okay, next question, control system. Okay, so yeah, more or less I can say 2 questions are good from signal and system. I mean, this is conceptual, easy. I mean, but it's not very straightforward. Not very straightforward. Okay, and the other one, this one also has actually good period, fundamental time period of the magnitude. That is what I think confused the students. Okay, now coming to signal and system, the control system, the GS is given to you as 1 plus. Okay, acha, you are telling YT equal to cross code. Yeah, actually I got that question also. I think I forgot to mention here. I'll write down. I got that question. Okay, yeah, what is the question I got? Yeah, I'll write down what is the exact question. Yeah, so correct, YT is given to you as cross correlation between XT and G minus T. Okay, another question. I received it. I think I forgot to take it in the PPT. Cross correlation of the XT and G minus T. Okay, now if it is cross correlation, dear, if it is cross correlation, okay, then the cross correlation between a signal, okay, and another signal can also be equivalent to the convolution of the signal with the mirror image. Convolution of the signal with the mirror image. So we can also write this as XT convolution with G of plus T. If the signal is the G minus T, then the convolution with the mirror image of G minus T, mirror image of G minus T is the GT. Is that correct? It has to be the GT. Okay, so then what is the Y omega? So then Y omega is the X omega G omega. Is the X omega G omega. Okay. So confirm me if this is what was the option. I don't have the options for this one. Okay, dear. Which answer your friend you're looking for? Which answer? Just let me know. Okay, yeah. So coming back to this control system question, GS is given to you 1 plus 2s minus 1 upon s cube plus 5s square plus 3s plus 2. Okay. What are the number of zeros in the LHP? Okay, so basically number of zeros. Okay, so when you simplify this GS, it will become, when you add this, so it has to be s cube plus 5s square, then plus 3s plus 2s, so total 5s, and plus 22 and minus 1, so plus 21, divided by this s cube plus 5s square plus 3s plus 22. Now if you want the zeros, okay, that means there is a cubic equation. s cube plus 5s square plus 5s plus 21 equal to 0, which need to be figured out. Okay, which need to be figured out, and that means again RH criteria will be required. Okay, so if I make the RH criteria here quickly, s cube and s square, alternate coefficients 1 and 5. For s square it is 5 and then 21, s power 1. Okay, so sign change, no, not coming up. This is 25 minus 21, 4 divided by 5, and this is 0. So s power 0, this into 21 divided by this, 21 and 0. Okay, so then there are no zeros in the RHP, so all are in the LHP. Okay. Right. No sign change. No sign change means there is nothing in the RHP. So all are in LHP. It's a cubic equation. So all three must be LHP. Check this is the correct data. Check this is the correct data. The s cube plus 5s square plus 3 plus 2, 5s plus 21. Okay, and 1, 5 and 5, 21 correct. 25 minus 21. No sign changes there. Right? No sign changes there. No, Naresh, how left side is 1? Okay. They have asked the number of zeros. Okay. Number of zeros of this function, or what they have asked? Number of zeros of characteristic equation. If number of zeros of only this function, then 3 in LHP. Okay, then the 3 in LHP correct. If they say this is some open loop transfer function and zeros of characteristic equation, then it becomes a different question. Okay, correct. So let's assume zeros of this function in LHP, then it is 3. Okay, then it is 3 only. Done, dear? Okay, next question. Okay, let us move ahead to the next question. Okay. So, yeah, a Nyquist contour is given to you. The transfer function, okay, Naresh, no problem. Okay, the transfer function has no poles on j omega axis, and the Nyquist contour is anti-clockwise as shown, and Nyquist contour anti-clockwise, and it has shown to enclose 2 poles. Okay, the Nyquist contour has been shown to enclose 2 poles. Okay, and then that means there are 2 poles of the GSHS or 1 plus GSHS. Poles of GS or 1 plus GSHS is same only. Okay, then find the number of encirclements and the direction for the origin. See, 2 things they asked. There were 4 options, okay, which exactly I did not have, but there are 4 options. Okay, options are more or less talking about what? Encirclements of origin of the GSHS plane and encirclements of the origin of 1 plus GSHS plane. Okay, so guys, number 1, if I want to talk about encirclements of origin of the GH plane, okay, then the formula is Z minus P here. Why? Because and Nyquist clock, the contour is anti-clockwise, so the formula we use is Z minus P. Okay, okay, if it is clockwise, then P minus Z. Okay, so zeros, number of encirclements of origin will become how much? Zeros are not mentioned, or maybe they would have mentioned there are no zeros, that something might have been mentioned. So let's take it as 0 and P plus. Now there are 2 poles in the RHP. Okay, there are 2 poles in the RHP that is going to come up. Okay, there are 2 poles in the RHP that is going to come up, right? That is going to come up. Okay, but yeah, anything mentioned about the Z plus? That is what I want to know. I think we need to have some data about the Z plus. Okay, I think as far as the question I have got, there is no data about the Z plus. Yes, anybody? Zeros of the transfer function, or maybe if this Nyquist contour given clearly shown that there are no zeros. Okay, there are no zeros within this right half plane, in the entire right half plane. Okay, so in that case it becomes if there are no zeros, because poles are same only, or whether you talk about poles of GSHS or 1 plus GSHS, it is the same. That's what we know. Okay, that's what we know. Okay, so I think then in that case it is minus 2, that means 2 clockwise. And even if we talk about, Z plus is not given. Z plus, is it 0 given? Okay. No, zeros are not given in either case. Okay, so even dear, if you go to, okay, in this case Z plus means zeros of GSHS, zeros of GSHS in RHP. But if I want to talk about the encirclements of the origin of 1 plus GH plane, okay, origin of 1 plus GSH plane, or it is equivalent to the encirclement of minus 1 comma 0 of GH plane. Okay. Likita, counterclockwise means anti-clockwise. Clockwise means direction of clock. Anti-clock opposite to it. Anti-clock or counterclock both are the same thing. Okay. Then what is the formula we apply is Z plus minus P plus here also. But in this case, Z plus are known as the zeros of 1 plus GSHS. Maybe they have mentioned that the system is stable. Okay. Maybe they have mentioned that the system is stable. So zeros of 1 plus GSHS is nil. Okay. Is nil. Okay, and then n becomes again 0 minus 2 and that is equal to minus 2. That means 2 clockwise again. Okay, so both should be 2 clockwise in that case. Both should be equivalent to 2 clockwise in that case. Let me just check the question once again, dear. I think this is what is the question I got. Just a second, dear. Yes, let me know if there is any other data or maybe they have mentioned about stability. Just a second, just a second. Chalo, I think the file is not opening right now. Yeah, let's go to the next one. I'll see if this opens in the meantime. No, if they mentioned stable, na, see P plus is same. No, Bhanu, then also no, then it is twice clockwise only, na, no counterclockwise for minus 1 plus J0. Acha, options you are telling maybe like that, okay. And even I did not aware that whether it is a MCQ or MSQ question, whether it is MSQ or MCQ question, that also I am not, that data is not available with me right now. Let me see if there is any other data with the question. Just a second. Just wait for a moment. No, I don't think. Two times origin in GH plane clockwise, correct? Two times minus 1 comma 0 point. No, that is wrong. Yeah, correct. Then it is correct. There is some option matching with it. Okay. Two options of origin of 1 plus. No, then two options. Two times the origin of 1 plus GSHS in clockwise sense. That is also an option. Okay. Then it becomes MSQ in that case. Yes, guys. Maybe some data is missing. Okay. Some data is missing. There are no poles on J omega axis. Clockwise enclosing two poles of RH of the S plane. No, dear. It is MCQ. Then I think maybe the options that are in front of me are not correct. Okay, are not correct. Okay. Anyways. Okay. So see, if DS is a step signal, let's come to the next question. I'll see the correct version of that. Okay, if DS is the step input, okay, disturbance step input is given to you. This is some transfer function 1 upon S power n. Okay, the question is find the maximum integer value of n for the steady state output equal to 1. For the steady state output equal to 0. Sorry, not 1, it was 0. For the steady state output being 0. For the steady state output being 0. Tell me, have you got this answer? Okay, see, have you got this answer? Okay, so, first this is minus 1 by S square. Okay, I'll write this correctly. This is minus 1 by S square. Okay, so minus 1 by S square times Y. I'll write down the final output equation quickly. The output Y is minus 1 by S square times Y. Okay, this is minus 1 by S square times Y plus 1 upon S power 1, the disturbance input. Okay, whole multiplied by 1 upon S plus 1. Okay, so collecting the Y terms on one side. Okay, so 1 plus 1 by S square S plus 1. Okay, is equal to 1 upon S power n into the 1 upon S power n S plus 1 into the disturbance signal. Okay. Okay. Yeah. So if we want to simplify it, it becomes s cube plus s square plus 1. Okay, divided by s square s plus 1. Okay, is equal to 1 upon s power n s plus 1. Okay, multiplied by d. Okay, now the d has to be 1 by s because they mentioned it is a disturbance, step disturbance signal. S plus 1 cancelled, and what is the final y equation? The final y equation, 1s will also get cancelled here. So there is 1s in the numerator. Okay, s plus 1 got cancelled upon s power n. Correct, upon s power n, that is left s cube plus s square plus 1. Tell me if you have got some answer. This question, I believe, will be challenged up. This question, I believe, is going to be challenged, dear. Why it is going to be challenged? Okay, see. Okay, if I ignore this part, okay, see, what is the steady state output? Steady state output. What is the steady state output? You will take it as, by the final value theorem, limit of s tending to 0, s into ys. Okay, limit of s tending to 0, s into ys. Okay, so of course, you can multiply here s into ys. Okay, if you multiply s, this becomes s square. Okay, and then you can take, then you can try to decide what is the value of s. Rest all calculations, I hope that is correct only. S square and by s cancelled. Okay, yeah. So dear, if you take any, this becomes s square. If you take n equal to 1, so 1 s cancelled, answer will be 0. If you take n equal to 2, okay, s square by s square cancel, answer will be 1. For a moment, if I ignore this part, but what is final value theorem? Final value theorem is applicable, okay, applicable if all poles means poles of this SYS, okay, poles of YS, okay, are in LHP. All poles are in LHP or max one pole at origin. Okay, but you cannot ignore this part, and when you solve this part, you can clearly see one coefficient missing. Definitely there are going to be RHP roots. Okay, this will give you RHP poles. 100%. You try by the Routh-Hurwitz. And if you have RHP poles, okay, steady state value will be unbounded. So this question must be challenged. Okay, because it is NAT, there is no option. Okay, this is a NAT question and it has to be challenged if this is the correct question. If this is the correct question, then it will go to MTA. Okay, right. Then it has to be challenged and it should be marks to all. If this is what is the correct question. See, I'm telling you, if you put n equal to 1, if I ignore this condition, if you put n equal to 1, you will get your answer. Okay, steady state output equal to 0 for n equal to 1. Okay, but that conceptually it is wrong. Okay, so this question definitely can be challenged. Next question, dear. Okay, yeah. So there is a plant GS with the transfer function 1 by s square. This is 1 by s square cascaded with some compensator. What is the phase lead provided by this compensator for the closed loop pole at -1 plus minus j root 27 by 2? See, okay, what are the poles? Poles are roots of characteristic equation. Okay, so characteristic equation can be written as, okay, how much? GS into GCS equal to -1. Characteristic equation is 1 plus GSHS equal to 0. HS is 1. The forward path gain is G into GC. So what you want? The angle of this. Now when two numbers are multiplied, angle will be added. Angle G plus angle GC should be -1. I mean the angle of -1, negative real number, plus or minus 180 degree. Okay. Now what is angle G? Okay, add, what should be the phase lead so that you have a pole at -1 plus minus j root 27 by 2. Okay, at this pole. Okay, at this pole. So what is the angle G? First of all, see here. What is the angle G? S, if I talk about S, minus 1.5 plus minus j root over 27 by 2. If I suppose consider any plus part only, okay, so what is the angle corresponding only to this S? Okay, that is given by tan inverse root 27 by 2 divided by minus 1.5 y upon minus x. So this itself can be written as 180 degree minus tan inverse root 27 by 2 into 1.5, that is 3. Root 27 is actually 3 root 3. Okay, so this becomes 180 degree minus tan inverse, 3 part will cancel, tan inverse root 3 and 180 minus 60, 120 degree. Okay, but when I come up here, okay, what is the angle G? Angle G means angle of 1 by s square plus angle GC is equal to 180 degree. Now, if angle of S at that given value of S is 120, so angle of S square will become first of all negative and twice of this value, twice of 180 degree plus angle GC is equal to 180 degree or plus or minus 180. Now, I choose minus 1 because I want the lead, the positive angle, the leading angle. So, what is angle GC? 240 minus 180, 60 degree. 60 degree. Correct, dear? Then it is 60 degree. Tell me if you have attempted and if you have got some answer corresponding to it. Okay. Next question, dear. Next question. Okay. Yes, control system question again. Okay. Control system question again. There is again a plant GS cascaded with the some controller. Okay. That is GCS. What is the choice of GCS? Okay. What is the choice of GCS which cannot stabilize the closed loop system, where GS is A upon S square minus B square. Okay, A upon S square minus B square. Okay. So, definitely let's work it out on the system, but normally P controllers, only proportional controllers are not for stability, they are for reducing the errors. Okay, this was alone D controller, I think. Yeah, it was not I, it was D. PI, PD, P and D. Alone derivative controller also, will not improve your stability. Okay. PD definitely is a preferred choice for improving stability, but with the numbers we'll see, and PI also may make it stable. Okay. But then all depends on the transfer function and the numbers given. So there is the GS A upon S square minus B square. A and B are positive, correct? A and B are positive. So if I talk about closed loop stability, basically, if you take about P controller, let me start with the simple case, P controller. P controller, so what is the GC? What is the GC of the P controller? It is some constant Kp. Okay, then how your characteristic equation will look like? Characteristic equation will be 1 plus A upon S square minus B square into Kp. These two are cascaded equal to 0. See, S square minus B square plus AKP equal to 0. So, S square equal to B square minus AKP. Now, there are two conditions here, dear. Okay, the S square answer may be positive or negative. If it is positive, S square equal to something. Okay, if it is positive real number, let's assume real, A and B given positive means there should be some real numbers only, then only they are given as positive. Even if S square is positive, suppose 4, so S may be plus or minus 2, 1 RHP, 1 LHP. Okay, if S square is negative, then pure imaginary roots. Okay, so what are the two conditions here? Okay, there are two conditions, maybe 2 imaginary roots. Okay, or 1 LHP, 1 RHP root. So that means definitely system is not stabilized. Okay, it may be maximum marginally stable. It may be maximum marginally stable. Okay, now let's go with the D option. Let's complete the simple parts. If it's a derivative controller, okay, so what is the GCS? Only SKD. Okay, only SKD. So characteristic equation 1 plus A upon S square minus B square into SKD equal to 0. Okay, so S square, okay, plus ASKD, okay, plus ASKD, am I correct? Minus of B square equal to 0. Done. This is also not going to stabilize. See na? S square plus ASKD minus B square. This is also not going to stabilize. This is also not going to stabilize. Why? Because see here, this is minus B square. Okay, and if it is minus B square and there is a sign change. If I start with plus B positive, okay, the square will be definitely negative. Okay, sign change. This is plus, this is minus. A positive, KD, let me assume positive, but 100% sign change. Okay, sign change means unstable. Sign change means unstable. Sign change means unstable. Okay, done. Sign change means unstable. Let me check all goes right. Right. Okay, so let me see the options for this only. No, only D controller will not stabilize it. Okay, only D controller will also not stabilize it. Whether it was only D or only I, just let me check it once again. It was, I think, only D, PI, PD, P and I. No. It was I only. Sorry, dear. It was I controller only. Sorry. It was I controller only. There's no typo error. Okay, so D option means, okay, I'll recheck it. But even if it is D controller, it is not stabilizing, I told you. So I'll correct it. Okay, so what is the controller gain in this case? Some Ki upon S. Pure I controllers though are never used. They are always harmful. Okay, that we have, if you have listened to the earlier lectures, okay, into Ki by S equal to 0. So see, S cube. Okay, there is going to be this term, that is S cube. Okay, then minus B square S plus AKI equal to 0. 100%. See, sign change also, S square missing, 100% unstable. You should not even apply RH. There is a sign change also and there is a missing coefficient. S square coefficient is missing. Okay. Now, let's come to the PD. Okay. Let us come to the option number B, and that is the PD controller. Okay. So, if you take PD controller, what is the gain of the controller? It is written as KP plus SKD. KP plus SKD. Then, what is my final characteristic equation in that case? The characteristic equation should become 1 plus A upon S square minus B square cascaded with Kp plus Skd equal to 0. So solving it, it's going to be S square, okay, minus B square plus AKP plus A, okay, or SAKD equal to 0. So this can be rearranged as S square plus AKDS plus AKP minus B square. Now this can stabilize. Okay, this can stabilize. Okay, of course with some condition. A is positive. Okay, so what you have to choose? Okay, you should have the value of Kp such that AKP is greater than B square. If AKP greater than P square, this will be positive. This will be positive. Okay. So PD controller can definitely stabilize. If I talk about the A option, that is the PI controller, okay, whose general transfer function will be Kp plus Ki by S, and characteristic equation will now look like 1 plus A upon S square minus B square Kp plus Ki by S equal to the 0, and when you solve it, S cube, okay, then there is going to be, sorry, let me multiply S, and then what it is, S square minus B square. I've multiplied it completely, so then I have A into SKP plus Ki equal to 0. Yeah, so S cube, okay, then again only S term is there, and that can be taken as with AKP minus B square. A into Kp minus B square into S plus AKI. Okay, again dear, S square term missing, it cannot be stable. S square term missing, it cannot be stable. It cannot be stable. Okay, so question is, which of them cannot stabilize? Okay, so here Pi also cannot stabilize, P cannot stabilize, I cannot stabilize, only PD can stabilize. Only PD can stabilize. Let me know if you solved this actually. Let me know if you solved this question actually. No, Guru, except PD. Pi is not able to stabilize, PD is able to stabilize. PD is able to stabilize, Pi is not able to stabilize. Pi is not able to stabilize. Okay, so Pi, P and I, these three cannot stabilize. Okay, Guru? Yeah, this was a MSQ question. This was a MSQ question. Okay, next one. That's it. These are the questions I got. Okay, around some 18-20 questions I think we have discussed in the session. Now guys, okay, tomorrow at 5:30 p.m. Okay, tomorrow at 5:30 p.m. Okay, the entire team of home is going to come up with the doubly discussion, the doubly live analysis, and tomorrow we are going to cover majority, or you say almost all the questions. Okay, we are expecting all questions only tomorrow, so stay live 5:30 p.m. onwards, and for doubly all the questions, okay, whether it is mathematics or common subjects like signal control, network, digital, or even the core subjects like machines, power system, all are going to covered up. Okay, so that's going to be a good discussions for doubly 2025 GATE paper conducted. Okay, dear. So thank you. Thank you. These are what some around 18-20 questions from these subjects which I mentioned. I've covered mathematics, signals control, and digital. Okay, so if any EE students have watched it, they would have also got an idea how the paper was, and yeah, that's it. All the best. Tomorrow is a double E examination. All the very, very best. And if you're EC, you have 2 more weeks. Okay. So, and if you have specially attempted the IN examination, then definitely, okay, definitely, you might have got an exam atmosphere, feeling how the exam was, what type of mistakes, whether you, took the pressure in the exam or what happened. Okay. Okay, Subodh, all the very best. All the very best, all double E aspirants. Do your best tomorrow. Don't worry, don't panic. You have done good till now. So you'll do it tomorrow. You'll do your best tomorrow. Okay, dear. Bye bye. Thank you. Stay safe. Good night and take care of yourself.